This video we'll be looking at place value. Our learning intentions: I will learn the place value of each digit in a number, and I will learn to arrange numbers in ascending and descending order. Our success criteria are that I can state the place value of any digit in a number, and I can list numbers in both ascending and descending orders by comparing the place value of each digit. Let's look at place value. If we have a number, which we can call a basic numeral, we might have this number here, 1893. This number is made up of a set of digits, and in our numbering system, which we call decimal, those digits are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Putting those digits in any order, we can create any number. Each digit has a number that is a value based on its position within that number, and this is referred to as its place value. The first few place values are ones, tens, hundreds, thousands, and tens of thousands. So let's have a look at this number, 1893. We can expand this number out into each of its place values. The 3 goes into the ones column, the 9 goes into the tens column, the 8 goes into the hundreds column, and the 1 goes into the thousands column. So we can have this as 1 times 1000, because we have 1 in the thousands column, 8 times 100, because we have 8 in the hundreds column, 9 times 10, because we have 9 in the tens column, and 3 times 1, because we have a 3 in the ones column. So we have 1 times 1000, plus 8 times 100, plus 9 times 10, plus 3 times 1. Of course, that would give us the same number, 1893. So when we have the number like we're used to, like this one here, we call it the basic numeral. And when we expand it out, like we have here, we call this the expanded form. Now, if we want to order or compare numbers, we do this by comparing the different values of the digits in their place value. So for example, which of these two numbers is bigger? A is 853, or B, which is 882. Now you can probably tell just by straight away looking at it, but let's understand why. We're going to start from the biggest place value, which is always the value furthest to the left. So if we look at the first value, or the left-hand value of each number, they are both 8. And of course, 8 is the same as 8. Neither one is bigger or smaller. So that place value, which is the hundredths, does not give us an indication of which number is bigger or smaller. If we now look at the second place value, in this case, that is the tens place value. In A, we have the number 5, and in B, we have the number 8. And of course, we know that 8 is bigger than 5. So of course, that means that the second number, B, must be the bigger of the two numbers, because the biggest value that we can see a difference in is in the tens column, and that has an 8 compared to a 5. So when we sort a list of numbers, we need to look at the place value of each of those numbers, of each digit in each number, to determine which one is either bigger or smaller than whichever other one we're looking at. And we do that in order until we find them in a list of biggest to smallest, or smallest to biggest. When we go smallest to biggest, we call that ascending order, ascending meaning getting bigger. And when we sort a list of numbers from biggest to smallest, we call that descending order. So again, going from biggest number down to smallest. So if we look at the first set of numbers, we have 1123, 1130, 1200, and 1235. So if we look at the first place value, the thousands column in each one, they all have a 1. So none of those tell us that anything is bigger or smaller. If we look at the second place value, these first two have a 1, and the second two have a 2. So these first two are definitely smaller than the second two because they have ones compared to 2. So we would have to now look at the third number across to see which of these is smaller. So here we have a 2 compared to a 3 in this number. So this first number must be smaller than this second number. And again, in the second two pairs, if you like, or the second pair, we have a 0 here, and we have a 3 here. So 0 in the tens is certainly smaller than 3 in the tens. So that means this number here must be smaller than this last number, which gives us this overall list of numbers. In a descending order, so going from biggest to smallest, the same process. We'll look at the first number in each, and it happens to, again, all be a 1. So that doesn't help us. We'll now look at our second place value, which is the 100th column, and they have 2s for the first two numbers and 1s for the second number, so we've got two pairs again. So to work out which of these first two numbers is bigger or smaller, we look at the third or the tens column now, and so a 3 is certainly bigger than a 0, so that makes this one the biggest, followed by this one. And then in our second pair, we have a 3 and a 2, and again 3 in the tens is certainly bigger than 2 in the tens, so that makes this one bigger than the last one, which gives us our descending, so from biggest number down to smallest number. Now when we talk about ordering and comparing values, there's a set of symbols that we often use when we want to write out an equation or a statement that makes sense. So here they are going down the left hand side. The first one is equals. So we are basically saying that two values, one on either side of that symbol, are equal mathematically. Now it's important to remember that that doesn't mean that they are the same, it just means that mathematically the same. So here we have the number 5 by itself. That is not actually the same thing as 2 and a 3, but when we add those 2 and 3 together, we get the value 5, which of course makes both sides equal to each other, the same as each other. They don't have to physically be the same, but they have to mathematically be the same. The next one we have is the not equal to, which is just an equal sign with a line put through it. And that basically says that either side, the left-hand, right-hand side of the equals are not the same. So 2 plus 3 in this case, which would be equal to 5, is definitely not the same as the number 10. We then have a greater than symbol, which basically says that the left-hand side in this case is greater than the right-hand side. And we know it's greater than on the left hand compared to the right because we look at the opening and closing of the little symbol. So think about this side of it here is bigger than the point which is there. So this side is the big side, has to be less or bigger than, the pointy side, which is the small side. We have another symbol that's very similar, which is greater than or equal to, so it has a little line underneath. So again, it's saying that the left-hand side of this equation is greater than, or it can also be equal to the right-hand side. And again, we think about which side's got the bigger opening, which is the left-hand side here, and the pointy side for the smaller side. So 2 plus 2, it's not actually bigger than or greater than 4, is it? It's the same. But this still works because we have the equals to part. So 2 plus 2, which is 4, is greater than or equal to the number 4. It is equal, so that's still true. And we now have the kind of reverse, if you like. We have the less than. So now the pointy side is pointing to the left and the open big side is pointing to the right. So we're now saying that the left-hand side, the 2 plus 2 in this case, is less than whatever values are on the right-hand side. So 2 plus 2 is 4, and of course 4 is less than the number 5. And again, we have a less than or equal to, same process before. 2 plus 3 is 5. It's not less than 5, but it is equal to 5. So this is still true. And the last symbol we'll look at is this squiggly equals, which basically means it's approximately equal or approximately the same. So we could, in this case, say 3.1. So 3.1, so it's got 1/10, is approximately equal to 3. It's not exactly the same, but it is approximately equal to the value 3. So let's have a look at some sample questions that you might see. What is the place value of the 7 in the values 3,781? So if we think about the place values, so we have 3, 7, 8, and 1. Okay, so the 1 represents 1 times 1, so the value 1, which is here, multiplied by the position 1. This second one is 8 times 10s. Then we have 7 times 100, and then we have 3 times 1,000. And of course, they're all added together to give our final answer. So the 7 is in the hundreds column. So the correct answer in this case would be C. 7 represents the hundreds in the column. So we have 3,000 plus 700 plus 80 plus 1. Which numeral represents the thousands in this number? So which one is the thousands column? So again, if we think about it, we have 3, 4, 8, and 9. I'll space them right out for some space. So this is our ones, this is our tens, this is our hundreds, and this must be then our thousands. So the number in the thousands column is, of course, the number 3, or the numeral 3. So the correct answer would be A for 3. How do you... Oh, there's a bit of a typo here. How do you write 1,253 numerically? So we're missing a word in the question there. So how do you take the worded value 1,253 and write that as an actual number? So let's think about that for a second. So we've got our ones, our tens, our hundreds, our thousands. Okay, we have 1,000. We have 200, so it must be a 2 there. We have a 50, so what do we get to get 50? Well, that's 5 tens is 50, and we have 3, so we have 3 in our ones column. So we think about our table, it would look like this, and of course that gives us our answer, 1253, which is number C, or part C, I should say, for the correct answer. Which of these shows the following numbers in descending order? So we have 100, 128, 324, and 99. Now the first and most important thing is to make sure we understand which sort of order, and it is descending. That means we're going from the biggest number down to the smallest number. Don't get mixed up between ascending and descending. So let's start by looking for our biggest number. So we'll start with the biggest place value, and that is the one to the left-hand side. So in the first case, we have a 1, a 1, a 3, and technically a nothing, because 99 doesn't have anything in the hundreds column. So which of those is bigger? It's the 3, so that must mean our very first number is 324, because it has the biggest value in the hundredths column. Now, a good idea is to cross it out of your list to make sure that you don't use it again. So let's look at the 3 remaining numbers. So we will now go to the tens column to sort this out. So here we have a 0, then we have a 2, and of course technically we have a 9. Okay, but let's not get confused with this one, because there's still a 0 at the front here. So which of these is bigger? Well, 99 is not bigger, because we've still got a 0 or a nothing in the hundreds here. So we're really just looking at these first two numbers, 100 or 128. And of course, a 2 in the tens column is bigger than a 0 in the tens column. So the next biggest number is 128. So we'll cross that one out. Now we're looking at the last place. So we've got a 0 in our ones column, and we've got a 9. Okay, so of course, remember this is still a 100 though, so we had a 10 in front, so nothing. This is always going to be our last one. We can just tell straight away. So 100 will be the next one for 100. And of course, 99 has to be the smallest, because it didn't even have anything in the hundreds column, so that's always going to be the smallest of our numbers. So which one of these matches up? 324 has to be first, and there's only one already that looks like it could be correct. It's this one here. But let's make sure. 128 is our second number, 100 and 99. Yep, so D is our correct answer there. Which of these numbers is largest? Right, so again, it's a bit similar. We're going to start by looking at the furthest left-hand column, which in this case is going to be our thousands column. So we've got ones, tens, hundreds, and thousands. So in our thousands, we have a 9, we have a 9, and we have a 9. So they are all the same so far. None of them stand out as being bigger. Next column down, we've got our hundreds column. So we've got a 3, we've got a 7, and we've got an 8. Okay, so out of those three numbers, the 3 in the hundreds makes this the smallest one. So that's out of contention right now. We don't know it's that one. But we've got a 7 and an 8. So which one of those two is bigger? Well, of course, the 8 is bigger. So this must be our biggest number. It's got the biggest value in the hundreds column of any of those. So we'll get rid of this one. So our answer must be 9821. We just have to find which one that is, and it is B. And this question is asking us to place the symbol that will go in the box to make the statement true. So here we're thinking about those symbols less than, greater than, equal to, all those symbols that we saw earlier. Which symbol of the two given can we place in that box to make this true? So we have the number 97,691, something in the box, 206,012. We've got a choice between this one and this one. So of the two symbols we have, A is the greater than symbol because the big gap is on the left-hand side pointing to the smaller gap on the right. And B is the less than symbol because on the left-hand side we've got the pointy bit and on the right-hand side we've got the big opening. So which of these two numbers is bigger or smaller than the other? So 97,692, is that smaller or bigger than 206,012? Well, the simple fact that there are more digits in this number on the right-hand side, it actually goes up to the hundreds of thousands, means that this one is definitely bigger than the one on the left. But which of these two symbols would work? Can we use the first one? No, because the pointy bit is pointing to the number that's bigger. That doesn't work, but we can use B. So if we were to put that symbol in, 97,692 is less than, because the pointy bit's on that side, 206,012. So we can read it as 97,692 is less than 206,012. Or we could technically read it the reverse and say 206,012 is greater than, because we've got the greater than symbol, if we look at it that way, 97,692. But because we tend to read mathematical equations from the left going across to the right, we'll stick with the idea that this is the less than symbol, which means 97,692 is less than 206,012.